Greetings, everyone. So let's go over the homeworks from coding and gaming trees. And so our first thing is about the Huffman code. So this is, we have to develop the Huffman code for these frequencies here. And okay, I'm not going to do what the book suggests is by putting them all in order each time. But for now, let's say, which are the two ones that I'm going to combine, the two lowest ones. So we're going to combine these two. So we can, this is the tree here where we're going to have C and F. Where goes what? Remember, the biggest one goes left. Big or highest. Write it here. Highest is left. Okay, so F comes here, C comes here, and then this tree has now we put them in a bag, and so we put the two weights together. There's now weight 0.12, and then we have let's draw the other guys. We have A still. Oh, I should do it the other way around, I guess. Right. So A, and then this 0.0. So these two are gone now. We have B is 0.25, D is 0.15, E is 0.30, and G is 0.08. So we have to combine the two lowest trees, and this would be these guys. Okay, and A is here the biggest, so we put A on the right. So this becomes, here comes A, here comes G, and this node tree will now have weight 0.18. So these guys are gone. Okay, so we have now 0.12, 0.18, 0.15, 30, and 25. We have to combine the two lowest. So in this case, that will be these two. Let me color them. This guy and this guy, right? Okay. So this will be, I'm just drawing these trees as I don't care as much where they go as long as I delete the old ones. So what is this? 0.15 is the biggest, so this side, the left side will be D, and the other side will be that package that consists already of these two guys, F and C. Okay, and what is now the total weight? Well, the sum, that is 0.27. Okay, so now these are gone. So what we have this 0.18, 0.25, 0.30, and 0.27. The two lowest are these, so you have to be combined. This one is the biggest, so this will be on the left. Okay, so I'll do this. Let me mark this. These two, I'm going to combine these two, right? Yes. So, which one was the B was the biggest? So it goes left, and the other package, because it's already a 3, goes on the left. A G, right. A B, A G, A B. So in total, we had 43. Okay, so these are gone too. So what we have left? We have a 0.30, a 0.27, 0.27, 0.30, and 0.43. So these are the two that we have to combine now. Okay, I'll do this here. So the 0.30 is the heavier one, so that will be E. Will come here, and the other is this whole tree that we have already constructed. So this will be D, F, and C, and this is here. And what is the weight of this thing? 57. And so what is, I didn't circle it anymore, so this is gone and this is gone. So the only two trees left are these two. They have to be combined. The biggest one, which is this one here, will come on the right. Okay, you go on the right here. Okay, and then you go on the left. Okay, and I put the yoke together in one big tree. And this now, if you add it up, it's exactly 1. So these weights can go now. Don't need to keep them. And so here it is. We have our coding tree, Huffman coding tree. And so just, I don't know whether it was asked. Oh, it asks about what is the average number of bits required to encode a symbol. I didn't address this, so I'm going to ignore that problem. I don't think it's so interesting. The reason that I omitted is because we have not covered chapter 7, which is about probability and expected values. This belongs more properly into that. It relies on material of that chapter, so I don't want to discuss this. But instead, I want to discuss, like, say, okay, let's put the word cage. How do we encode the word cage? Well, remember, left is 0, right is 1. So now we're going to label all the edges. That's different from what we did before, right? That was giving weights to the vertices. So in fact, I can now get rid of this weight because it has to be 1. We know this is correct. And so now I have names for the edges, or these codes for the edges. So C, what's the path from the root to C? It is going left, right, right, right. A, to go to A, I have to go right, right, left, right, right, left. It seems strange, right, that you can put these ones so next to each other and that you don't have to bother, that you don't have to write here a line between. It's exactly the reason we have explained it in the lecture that a binary trees, if you use the leaves of that tree to encode your characters, it is only one way of reading any code. If it's at all valid, some codes might not be valid. Okay, so that was A, G, right, 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 and then finally E. E was left, 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 left. So this is the word cage. Okay. Let's see. I'm going to write an arbitrary sequence and see whether this what could this be. Can this be something? Just to show you. Okay, what do we have to do? We have to follow these instructions. So it says right, then left. Okay, that leads to this 2 leads to B. Okay, then it says right, and then left. Sure, that is again a B. Okay, so that is B again. The next, again, start from the root. And what does this tell me? Left, and then right. So left. So sorry, left, right, right, right. That gives me C. And that this is another B. Okay, let me put another 1 here. Just for some reason, it just worked. Okay, so I put a 1 here. Now I have a 1 left. So go right, but there is nothing right. I mean, there's not a leaf yet. I've not arrived at the leaf yet. So that is basically also a checksum. That we remember we have seen these things in discrete math 1 to see whether the codes that are transmitted are valid codes. If you end up with something that is meaningless, you know there was a mistake made. Okay, because this single 1 does not lead to a leaf, and therefore it's not part of a code. Okay, so let's move on because it's homework, it's not lecture, right? So let's go to number 35. Now 35 are 3 different ones, so I'm going to do only B and C. It is a game of NIM with a payoff, and the payoff is I'm interpreting it as the level that the guy loses, that's how much he has to pay. At the level that you lose, that's how much you have to pay. I'm not sure that is exactly what they mean, also because they treat it slightly differently than I did, because winning, and I always think of the final positions, the positions in which no final move exists anymore, and that I call the leaves. And in the game of NIM, they kind of were not doing that. 2 piles with 2 and 4 stones. So we have 2, 4. That is our root. Okay, what are the possibilities? From the first pile, if I remove everything, I get 4. If I remove 1, I get 1, 4. From the second pile, I can remove 1, I can remove 2, I can remove 3, or I can remove everything. So quite a lot of children here. Perhaps I should put them a little bit farther apart. So let me do this again. Let me put it, sorry, that's not farther, right? Here is farther. No, that's still not far enough, sorry. Let me do it one more time. Let me get my stripes on. Or my, that's better. Okay, so we put here 4, 14, 23, 22, well, 2, 2, 2, 1, and 2. Okay, so let's get rid of this now. Let's draw lines. These lines are not really, I mean, okay. It visually helps a lot if we draw these lines. Okay, in position 4, there's still a couple of things you can do. What can you do here? Well, you can take 1 away. You can take 2 away. You can take 3 away. Or you can take even 4 away. Let's perhaps put that here and leave with 0 here. Okay. So, okay, let's see where are we here. This is maxes. This was now min was playing, so this was min. In 1-4, well, you could either take the first 1 away, then has 4, and if you start taking from the second pile, you can have 1, 3, 1, 2, 1, 1, or just 1 if you take the whole 4 pile away. From the position 2, 3, if from the first pile you take away 1, you get 1, 3. Yeah, now I'm writing underneath, and I'll alternate a little bit. If I take both away, then I have 3. Or I start taking from the second pile. If I take 1 away, I have 2, 2. If I have 2 away, I get 2, 1. And if I get 3 away, I get just 2. Okay. From the position 2, 2, I can take from, it doesn't matter which pile, I can take 1 away. So 2, 1. Yeah, I said I should always write it this way. I'm not doing that. It's not so important. We just have to make sure that we don't double a node. And even that is not really a problem. If you do that, you don't make mistakes. So either this or that. Those are the two only possibilities, right? Yes. And then 2, 1. Well, you can take 1 away from the biggest pile. You can take 1 away from the second pile, or you can take the whole left pile away. And then 2, there's only 2 things you can do. You can either take 1 or you can take 2. And so that's the result. Okay, that was for max again. Remember, zeros are losing positions here, but now there's a payoff, right? At this level, if you win, if you start, okay, that's level 0, so it doesn't count. If you would win already at this level, you would get $1. If you win at this level, you get $2, $3, and so forth. Yeah. All right. So what's next? 3. Well, 3 has quite a lot of possibilities because I can go to 2, again go to 1, and again go to 0 here. 2. There are only 2 possibilities. 1. There's only 1 possibility. That's already a leaf. 4. You see, some of these are rather dull paths because they just are taking things away. Here's at least a little bit more. I can take the first 1 away, or I can keep that 1, and then I would have these combinations. 1, 2. Okay, I can take that 1 away. I can take 1 from the second, or I can take 1 from the second. This one is very simple. That's just 0. Here I can have 3. If I take the first one, if I leave the first pile, then I have 1, 2, or 1, 1, or 1. I don't have 1 yet here, not in this part. Okay. 2, 2. Now you see it's getting really crowded here. So 2, 2. I can have 1, 2. Or if I take a whole pile away, there's 2. Or what else? Well, that's the only two things I can do, right? I take 1 away, 1, 2, or 2. Yeah, right. Okay. 2, 1. That is either 2, 1, 1, and 1. Okay. 2 we have, 2 has come already a couple of times, right? So we have this 2 already. So we have here 1 and 0. I'm sorry, this is getting worse and worse. 2, 1, we just did that, and 2, 1 has 3 possibilities, namely 2, 1, 1, and 1. What was this one? Oh, that was 2. So much thing that I don't see it anymore. I'm gonna have to go cross away here, because otherwise I'm gonna do this in different color that I keep a little bit better what I'm doing. But oh no, not this one. So what did I do now? Okay. Did 2 here, right? Okay, this one. Let me go here. I can do 1 or 0. Yeah. 1, 1. Well, there's only one thing you can do. In 2, there are 2 things you can do. A 1 or a 0 pile. In 1, there's only one thing you can do. 0 and 0. Okay. I guess I had actually enough space. I was impatient. Okay. So now, this was in, where were we? This all happened in min situation. Okay, we're getting there. We're not always there, because this still has 2 possibilities. This only has 1 possibility. This is already a leaf. 0. This unfortunately has 3 possibilities. 0 here. 1 and 0. That's 0. Okay, it is 3, again 3 possibilities. 2, 1, or 0. 1, 2. 1, 2, that's either a 2, 1, 1, or a 1. 1 only gives me 0. 2 only gives me 1 or 0. 1, 1 is only possible thing is 1. This is only 0. Here we have 3 possibilities again. 2, 1, or 0. What is the next one? Is 1, 2. 1, 2, unfortunately, also has quite a lot of possibilities still, right? That is a 2, 1, 1, and 1. This one, okay, that's just 0. 1, 2. 1, 2, well, there are 3 possibilities, right? So there were 2, 1, 1, and 1. Where am I now? 2 possibilities. 1 and 0. Okay, now it's really getting really bad, right? So I'm going to cross over again. So I did this 2, but I think there's another 2 here that I have to do. Of course, I have to do everything, because they come from different parents and they therefore affect the result differently, but possibly. So this 2 is either a 1 or a 0. Then this 1, 1 can only be a 1. This one can only be a 0. And the same for this guy. This one can either be a 1 or a 0. Right, so that's 1 too many. It's either a 1 or a 0. This 1, 1 is either, no, that's only possible is 1. This is 0. And then don't forget, I have still a couple of guys downstairs there. Sorry, I get a little bit entangled here with my own thing. Okay, what else were there? This one here, that will give me another 0. There is this one that also gives me 0. And this one that also gives me 0. I hope I can still read this when I have to go put it all together. Unfortunately, you see there's still 2 more steps to go, right? So this was all in max's range. Now back in min. We're going to get a 0 here. Here we're going to have still 2 possibilities, a 1 or a 0. This is just going to be a 0, a 0, a 1 or a 0, a 0, a 1 or a 0. That can only be a 1. Where was I? This is a 0. That's a 0, 0. This is a 0, 0. This is either 1 or 0. This one is a 0, 0. This 2 is either 1 or 0. I can see why the book skips one step, so to speak, because it makes it a little bit shorter. But I don't know, it confuses me, so I don't want to do it. 0, this 2. Why are there so many 2s still there? 1 or 0. This one, that's just a 1. This one is just 0. This is also just 0. And then these few guys, this is a 0. This is a 0. This is a 0. And I hope that this was a 1, so that this is actually a 0. Did I get this right? Yes. Well, okay. I kind of lost already. This is going to be horrible. Okay. All right. So one more thing. This is max now. So we're going to get a 0 here, a 0 here, a 0 here, a 0 here, a 0 for this one, 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 and a 0 for this one. It's very likely that I overlooked something. But let's now say, what is it that we need to do? I could have made some mistakes in the way, but let's not dwell on that. Okay, so this is max. Max is territory, and each of these positions are losing positions for him. So, and in fact, he has to pay the level of each of these, what the level is. What level are we in? So let's light the level in blue, perhaps. So this is 0 level, so it costs only $0. This is $1. This is $2. This is a $3 pay. This is a $4 pay. This is a $5 pay. This is a $6 pay. That's quite expensive. Now he is losing, so each of these have value -6, because he would have to pay that. Okay. In here, these are, if min has to play zeros here, he will lose. And therefore, this is a +5 for max. It's always from max's perspective, so this has value 5. What's the value of this one? Well, this is just a child. It inherits it from a child. It's the maximum, it's the minimum that we have to take, but it doesn't matter because there is, so this is 5, this is 5, this is 5. It inherits the -6, this is 5, this is 5. It inherits -6. This one is 5, this one is 5, this is -6, this is 5, 5, 5, 5, -6, 5, 5, -6, 5, 5, -6, 5, -6, 5, -6, 5, 5. Okay. This is the max. So the zeros here, the losing situations cost him, and this so cost him $4. So -4, -4, -4. Now what about this one? Okay, this is the first time we need to do something substantial. We are in the max situations, we take the max of these two. That is good news, because that is a 5 here. So this becomes 5. This just inherits. This is a losing position, so it's -4. This is inherit, so it's a 5. This is a losing position. Losing positions in this area are all -4s, right? So -4, -4. This 2. We have to take the maximum of -6 and 5. That is good news. That is 5. This inherits the 5 from its parent. This is a losing position. This 2, again, maximum of -6 and 5, so this gets 5. This one inherits, what does this one do? I'm sorry, I think I made a couple of mistakes here, right? I said this, the ones inherited from, yeah, this one was correct. Sorry, this one is correct, but 0, 0, this is correct. This one, yes, is still correct, but this one inherits. Oh, sorry, this is why I misread it. There's a 1 here hidden here. So this inherits from its -6. This is a -6. This actually is 1, 1. So this is because this has come a little bit. Okay, the 1 here that gets value 5. Sorry. This gets value, which one? This 5. The 0 is a losing position. This 1 comes from 5, so it inherits. This is a losing position. This 1 comes from 5. This 0 is a losing position. This 2 is a max is 2. For this one, I have a 5. For this 0 is -4. For this 2, it's a winning position, so it gets 5. I mean, it's a maximum, so I have 5. For the 1, 1 here, I have to take from the child. It's a maximum because there's only one child, so it's -6. That is a 5. That's a losing position, -4. This 2 is going to be a 5 again. This 1, 1 is going to be a -6, right? This one is a, what is this one? 5, right? Ones are 5. This is -4, -4, -4, 5, -4, 5, -4, -4, 5, -4, -5, -4, -4. Oh dear. Okay. Any 0 in the next row are losses is when min would lose. So this is good for max. Okay. So the zeros here will get value 3. But what are the other ones? We forgot even I even didn't see this guy here, 5. This 2 here inherits. What you have to do now, be careful. Now we have to take the minimum, unfortunately. So from these 2 we get -4 here, the value. Let me take a different color, otherwise I'm going to get completely overwhelmed with all my values. This is just one child. This is a lose for a min, so a win. So that's a +$3 here. This one is just a child, 3, 3, this 3. We have to take the minimum of these 3 possibilities. The minimum of 5, 5, and -4. Unfortunately, the -4 brings this value quite down. Here, this is also -4. This one, also -4. This is a win, 3. The 2, 5, 5, and -4 are the values of the children. Since we have to take the minimum, this will be -4. 1, 2. 1, 2 has, the values are 5 and -6. No. 5, -6 and 5. So then, right? So here, this 1, 2 has 3 children. These are the 3 children, if you can still see it. And I have to take the minimum, so that's -6. That's not good. That's a -6, expensive one. The 1, 1. Oh, I never did the 1, 1 here. So I'm going to calculate. Notice that in some sense, I'm doing way too much. I only need to look at each possible outcome at each possible level. Okay? So if I copy here all these various zeros, they always have, each 0 in this column has the same value, 3. Each 2 in this column has this, in this row has the same value. So I don't need to recalculate this every time. Okay? So and that's it's something that, for one thing, I'm saying this because I forgot to do this guy. Okay, so let's calculate what this would be. This 1, 1 can only come from has only one child, and that child has value 5 here. So this will also therefore have value 5 for the same reason. Okay, so this will have value 5. And so from now on, I'm going to just look for same ones and just start giving them the same value, that I don't need to do this all the time. Once we saw all have -4. These are all -4 guys. This is a -4. I hope that is a 1, right? Yes. This is also a 1. This is also -4. And this is also a -4. This is -4. This is -4. And this is -4. Okay, what else do I have to do? The 2's. The 2, what is, do we have calculated 2? Yeah, that's -4. Zeros, that is 3. What is this? That's a 3. Did we calculate? Yeah, 3's we know. We know the 3 is -4. Why is that? Oh, again, I didn't calculate it, so that's, no. Sorry, we're talking about this guy here. So this guy we did actually calculate, right? So it is minimum of 5, 5, and -4. So yes, that's true, -4. The 1, 2 was -6. See over there. The ones, what were the ones again? -4. The 1, 2's was -6, I just said. The 2's, what was it, 2? -4. So this is also -4. This is a 3. And this 2 was -4, right? Okay. I think I kind of got everything. Oh, there's 2 3's here. Anyways, we'll find out in the next level. Again, there are not that many different ones, so I'm only going to do the different ones and then copy the rest. Now I'm in situation that the play is again, this is Max's turn to play. So zeros here have value -2. At this point, the payoff is $2, right? Because in level 2. There's only 2 zeros here. So what is 3 here? Let's look at this 3. We are now taking maxes. That's good news because we have a -4, -4, 3. So this 3 will get value 3. So 3's everywhere where we have a 3, but that's the only 3 that we had. Oh no, there's another one here. And I forgot to deal with this 3. So there's another one. Okay. So I'm going to do a second exercise, and there I'm going to not work out the full 3 anymore. Okay, so where am I? 2. Yeah. What is 2? I have to take the maximum of these two, -4 and 3, so that will also be 3. So 2's are priced at 3. 3. Okay. Ones are also priced at 3 because they come from their children. So these are priced at 3, 3, 3. Zeros we already discussed. 4's. What are 4's worth? Well, if you have a 4 here, that's the maximum of these guys, so that's also a 3. Okay. 1 and 3, did we calculate that? No, not yet. So 1 and 3, there's 4 possibilities. And there are -4, -6, 5, and -4. Luckily, this 5 brings the whole thing up to 5. So 1 3's are worth 5. Okay. 1 2's, did we do already 1 2? I don't think so. 1 2's have 3 successors, namely a -4, a 1 1 that I never figured out. Well, I figured it out here. That was 5, right? Yes. 1 1's are 5. So the children of 1 2 are 2, 1 1, and 1. That is. And the maximum of this is luckily the 5 here. So 1 2's are priced at 5. There's another 1 2 or 2 1 is the same. 5, okay. 1 1's, okay, I haven't done 1 1's, and again, I forgot to draw it. You see how many things you forget to draw. There's so much drawing, right? In the 1 1, okay, there's only one thing you can do, right? In a 1 1, you see it here, there's only one, and that's is only one child, and that has value -4, so 1 1's also will have value -4. -4, -4. The 2 2, I haven't done 2 2, so that is 2 2 actually only had two children, a -6 child and -4 child. Oh, they are not good. So the maximum here would be -4. And I think I kind of got everything. All right. If we don't have anything, then we'll fill it up later. Okay. Next level, if there are still zeros, but there are no zeros anymore, so there are no leaves anymore, I have to take minimums of the children. So what are the minimums of the children here? 3, 3, 3, -2. What is 1 4? 1 4 has these children, And the minimum here is -4. It's not looking good. What is for 2, 3? What are the minimums? 5, 3, -4, 5, 3. So -4. What are 2, 2? The minimums are, well, the children are 5 and 3. The minimum is 3. Okay. Good to know there's at least one here. What's the minimum here? From 2, 1, it has 3 children, and the worst one is -4 because we're taking minimums. And 2 has a child 3 and a child -2, so the minimum is -2. So almost all positions are losing here for max, but luckily, the last step, we take the maximum of all the values that we have here, and that is 3. So this is a long, winding road that took us to find out that in this game, Max can make $3. And so again, how does he play this? Let me emphasize this. You always choose the neighbor with that value, 3. Okay? Now, with the highest value. Now, it's the term for min to play, and we don't know what min plays. The best play for min, what would be the best play for min, is to keep, he's losing $3. But if he chooses this, let's see what happens if he chooses this. Now, Max can go for $5. He just now have to choose the child that has $5, and that is this child. Okay. And at this point, because the 1-1, we know that the game is set. There's not much the min can do. It can only take 1 away and ends up here. Now it's Max's turn again. He takes that single one away. Where do we end? Here. No, no, it has to be down here. I lost track where I am. I'm sorry. Let me undo this. I am 5. What happened? Okay. Oh yeah, I'm green. Oh, I am green. That's right. So okay, right. So now it's my turn again. Max's turn. No, I'll get confused. Oh no, orange is, oh, I see, orange is Max. Max is orange. Okay, sorry, I got a little bit confused here. Although it's silly because there is nothing to do. This was, which position? Yeah, this is a 1. And after a 1, there's only one thing you can do, that is end up in the 0. So I think it goes here. I might even have forgotten to draw it. Oh no, it's this one. Okay, I see it now. Sorry, people. It's this one, right? Here we go, and that's the 0. So notice now min is losing because he cannot do anything, and he's at level 5, so that's why he has to pay 5. And that is because he made the wrong choice here. He didn't play optimal. So he made a mistake here. He should have gone, no, sorry, at this level. He should have chosen this path. So not only is this a strategy for Max to min as much as possible, it's a strategy for min to lose as little as possible, okay? Because Max will be the winner in this game. Now, the next one, I don't want to, well, this is going to be a long video, but that's okay. So this is now number 34C. And so we have 3 piles with 1, 2, and 3 stones. So we start with the position 1, 2, 3. Okay, let's see what are the possibilities. Well, I take that first one away, and it's a 2, 3. If I keep the first one and take 1 away, then it's 1, 1, 3. If I take both away, I get 1, 3. And now in the last pile, I start messing with the last pile. I have 1, 1, 2, 1, 1, 2, 1, 2, 1, but I'm going to write it 1, 1, 2. And finally, 1, 2, right? Because I can take all 3 away. So sorry, I hope that you understand this. What I'm doing is I take 2 away from here, so I have 1, 2, 1, but I write it as 1, 1, 2. Just do not get confused too much. Okay, and then we have 1, 2. Again, I didn't spread them out. Yeah, let me spread them out again. I'm sorry about that. I got to do this here. So this is 2, 3. I know I have to spread out, and then I'm talking so much that I don't pay attention. 1, 3, 1, 2, 2, 1, 1, 2, and 1, 2. Okay, so these are the children. So I should be a little bit, no, in this level it's okay, but later on I have to be a little bit more careful with my lines that I'm drawing. So, okay, this was max, and this is already in min territory. Okay, 2, 3, what are the possibilities here for 2, 3? In 2, 3, if I take 1 away from the first, and I have a 1, 3. If I take both away, I have a 3. And now I'm messing with the second pile, 2, 2. I take 2 away, then I get 1, 2. And if I take 3 away, I get 2. Okay, 1, 1, 3. I can take the first pile away and I get 1, 3, or the second pile. Gives me both the same. Or I can mess with the third pile by either take 1 away, take 2 away, or take 3 away. 2 away, sorry, take 3 away. This one, I can mess with the first pile. I get a 3, but I have already a 3. So, and now I'm going to do something which is not allowed to, but I've got it. That's where I'll let me do use let's make this. No, sorry, I have to do this here, black. So let me explain what I'm going to do. Let me actually do this gray. What I'm going to do is I'm saying, okay, this has 1, 3. If I take the first pile away, this gives me a 3. Now I know where the 3s are. Here. This is going to be the same as this guy. Now, this, but this dotted line is not an edge, because if that would be an edge, I would have a circuit, right? This would be my circuit. So that's not an edge, but I'm saying it's similar to that. So whatever value this one has will also be the values of this child. Now it has other children that are not the other childs. Now if this was messing with the first pile. If I mess with the second pile, I can have a 1, 2 pile, but again, that's already present. See, my whole thing is to not overload my graph here. If I take 2 away, I have a 1, 1 pile, which also already is something I have found. And if I take all away, I have a 1, which actually have not discussed yet. So let me make a separate note for this guy. Now, in a 1, 2, 2, I can take the very first one away, and I had a 2, 2. But I have this already, so this will be the same as this one. That's taking the first one. If I take the second one away, then I have 1, 1, 2. 1, 1, 2, yes, we have already discussed that. If I take both away, I have a 1, 2, which also is already there. Oh, we have this was already a child, yes. Okay, 1, 2 was already, was it? Oh, no. Yeah, I'm not so sure that these dotted lines are, I'm going to make them smaller because I'm afraid that I'm losing a little bit, they are too big a little bit, so I'm going to make them smaller, okay? I hope that the ones that I have so far is not a problem. Let's see, I took our best with the second pile, but of course messing with the third pile gives me the same result. So that should be it. I hope I didn't forget anything. Of course, if you forget even one thing, it could be the difference between winning and losing. Okay, so let's recap. If I take away, that's the danger if you do it this way, is now because you're messing, you're not systematic anymore, but otherwise it's way too much writing. So if we do this, and calculation, if we do this, so we can take this away, we have a 2, 2. We take 1 away, we have a 1, 1, 2. We take both away, we have 1, 2. And that's it. Okay, the 1, 1, 2. Okay, what can I do? I can take 1 away, and that gives me 1, 2. But I have 1, 2 already. Okay. So I should have now actually moved the other guys, the downstairs guys, a little bit farther apart, because you see, you get so much repetition that you don't need space anymore. So that's what's missing with the first pile. Messing with the second pile gives me the same result. Or now I can mess with, I take 1 away, or I can take 2 away. So nothing really new happens anymore. In the 1, 2 pile, I can take 1 away, then I have the first one away, then I have a 2. So this is the same as this 2. I can take 1 away from the second pile, or I can take the whole second pile away and I end it up here. Okay, so we see we are getting much less possibilities. Okay, this was, okay, we have to keep track here. This is min. Not that we need it now, but I like to keep track of everything. This is max. Okay, so where are we in? The possibilities. Either I take that first thing guy away and there's a 3, or I take 1 away from the second pile, 2 away from the second pile, or all 3 away from the second pile. Okay, what can I do with 3? I can take 1 away, 2 away, or even all. Okay, that's 0. 2, 2. I can take 1 away and I get 1, 2, which is something I already have a possibility that are discussed. Or I can take both away and then I get a 2. Okay. In the 1, 2 case, I can take the first guy away and I have a 2 left, 1 pile left with 2. And if I take 1 away from the second pile, I get 1, 1. If I take the whole pile away, second pile, I get 1. Okay. In the 1, 3 case, well, okay. This is at the time that I decided to not double do, I forgot that 1, 3 is already, we did already 1, 3. So I'm gonna make this already happen here. This 1, 3 already exists, so I'm not gonna bother about it. Okay, where am I? Yes, so this is something no longer here. Okay, so the 1, 1, 2. Okay, there. Possibilities. If I take the first pile away, I have a 1, 2, but that is exactly, that's already discussed here. Same with the second pile. In the third pile, I can take away, and that would give me a 1, 1, 1. Okay, or I take the whole second pile away, and then give a 1, 1 combination. 1, 1. I take 1 pile away, and that's it. There's only one thing I can do. Same here. I can only do one thing, and here only one thing. Okay. So you see, it's actually much less than it looks like, but there's a lot of duplication. This takes away the duplication, but makes it more cumbersome in our recalculation, you will see. Okay, keep going. 3, well, you can make 2 out of it, you can make 1 out of it, or you can make 0 out of it. 1, 2. If you take the first pile away, then you get a 2. If you take 1 away from the second pile, you get 1, 1, which is something we don't have yet. Or you take the whole pile away, the second pile, and then you have this guy. 1, 1, only one thing you can do. 1, only one thing you can do. 2, you can either take 1 away or both away. And the 1, only one thing you can do. That's leave. In the 1, 1, 1, you can take one of the piles away, and that's it. Okay, so you see it gets really much less. So what are the possibilities here? Well, let's see, keep track of what it is. So here, a 1 or 0. Okay. That's the only two possibilities. For 1, okay, that's the only possibility. For 1, 1, that's the only possibility. And then finally, so this is min. So this is the last of our possibilities, this is 0. And this is max. Now, max, okay, let's calculate the values here. Let's do it in blue again. This is $0, $1, 2, 3, right? 3, 4, 5, $6. And this is a losing position. So this is worth $6. It cost him $6 because it's Max's turn and he cannot draw. So a 0 in min's level would be a win for Max. So this is a 5, whereas the 1 just inherits the value from its child. Okay, now Max's level again, we take maximums. That's good news because this one is a maximum of these two, so that will be 5. Okay, this 1 here, notice this is its child, right? Its child is -6, so -6. And this is a loss for Max. You shouldn't have 0 Max, so this is going to cost you $4. And what is 1, 1? Well, it has only one child, so it inherits the value of a child, which is -6. We go to the next level, which is a min level. So we're going to have to take the minimums. So let's look at this one first. We have 5, -6, and -4. This is the worst of you. That is -6 for you. The 1, 2. The 1, 2 has a 5 a negative 6 child, and a negative 6 child. So this all costs you negative 6. The 1, 1 has only one child, so you inherit from that child. The 1 has one child, so you inherit from that child. The 2 has either a negative 6 or a negative 4, so that is a negative 6. The 1 inherits from the child. The 0, that's where you're going to make money, and the 1, 1 inherits from the child, so negative 6. Next level, 1, 3. 1, 3, luckily we are now back in a max situation, so we have to take the maximum of the children of 1, 3, which are this one, this one, this one, and this one. The maximum is only negative 4, so that's not promising. What is the next node, 3 here? What are it has 3 children of values negative 6, negative 4, and 3. The max is therefore 3. So that's actually not a bad one. That is value 3. The 2, 2 has 2 children only. No, wait, what's the children here? Let me trace it back. Negative 6 and negative 6. So yeah, it is negative 6. The 1, 2. The children of 1, 2. I got a little bit. What are the children of 2? Okay, see, that's what I was a bit worried about. The children is a negative 6 child. What else is there? There seems to be this one. Oh yeah, 2, there's also negative 6. And what else? And 1. This is this part. Where am I? So here, this part. What was I doing here? Negative 4. Negative 6, so negative 4. I hope that, I'm sorry, I didn't do this very nicely. I should have done this a little bit better. The 2, why didn't I not work out what 2 was? I forgot to do 2. Okay, 2 has 2 possible children here, so we are dealing with 2 here. So, okay, I'm running really out of space here, so I'm going to do this 2, I'm going to do this 2 here, okay? So this 2 can either have a 1 or a 0. So if you take the maximum, its value would be 3. So this 2 therefore also has value 3. The 1, 1, 2, it has children. This child has negative 6, this child has negative 6, and this child has also negative 6. So that's not a good thing. That is negative 6. The 1, 1, 1, it has only one child, which has value negative 6. The 1, 1 has only one child, value negative 4. The 1 has one child, that is a value 3, right? And yeah, that was already taken care of. Okay, we're going up. Now we have to take min. We have to take the minimum of all the children here. That is negative 4, 3, negative 6, negative 4, 3. So that is really bad. That is negative 6. What about the 1, 1, 3? The minimum here, we have 3 children, is negative 4. What about 1 and 3? The minimum, okay, we have to be careful here because what are the children? This is one child, that was 3. Then this was a child, that was negative 4. And then this was a child, was 3. So negative 4. Yeah. Oh, yeah. It doesn't look good for you, Mr. Max. Okay, so what is this? This child, see, this is where I was. Negative 6. It's the lowest possible, so I don't have to think more. Whatever the else is, it can never be more than negative 6, right? So negative 6. The 1, 1, 2 position. What are the children here? This is a negative 4. This is a negative 6. Okay, negative 6. So that is. And the 1, 2 position, it has what are the possibilities? A 3, a 3. Okay. I don't see anywhere where I'm going. Negative 4. Oh damn it! It's negative 4. So this will be negative 4. And now I have to take the maximum. Bad news is it's negative 4. All right, that's how it works. The book has formulated slightly different, and therefore their answer is negative 3, because I think they count differently. I don't want to think too much about it. My count is definitely correct, unless I make a mistake, but I don't think so. I don't think I made a mistake. And so, okay, that's what it is. And then the final question, I know it's a long video that I'm doing. I was gonna ask you, what did I ask you to do? Number 35B and, no, 35B, oh, that's what I just did. Oh, the matches, N is 11. So we start with 11, let's do back and back. I have 11, that is my node here. And I can take 2 or 3, so I can either have 9 or 8. So in 9, I can take 2 or 3. And here I can take 2. See, again, we are in the same situation. So I'm going to do this now a little bit. As I said, it is to minimize the number of computations, but it gets a little bit trickier. So hopefully in this case, because it's a binary tree, so there are much, much less branchings. So here we have this 6 here, and this is also a child of this guy, and then we have 5. Okay, so we can, here we can do 5, or we subtract 3, that's 4. That would be also by subtracting 2 here. And then the other possibility is 3. That would be also if I subtract 2 from there. And then finally 2. So this 5 here, that can either be a 4 or a 3. Now, that's also if I... wait. No, what I'm saying, people, I have to subtract... No, this is wrong, right? I have to subtract 2. So it's either 3 or 2. And if I subtract 2 from this, is that. Or otherwise, if I subtract 3, it's a 1. Oh, it's a 1. That's also what happens. What happened here? 3. Or I can take all away, and that's a 0. And here I have only one choice. If I have to take 2. Okay, so what's next? I can take 2 away, then I'm left with 1. Or I can take 3 away and have with 0. But now, of course, we're going to be very quickly done. If I take 2 away, that's this. And in these 2 are already leaves. Remember, 1s and 0s are leaves here. Okay, let's draw the levels. I'll do that in red, perhaps. So this was max. This was min. This was max. This was min. And this was max again. And this was min. Okay. So I'm going to do first the win fail and just do that in red. These are losing positions, 1 and 0. If it's min's time to do act, that will mean that max will win. So these are 1s for max. Now, we go to the next level and we have to take the max of these 2. So 3 will get value 1. What is the value of 2? Well, it just inherits it from a child. The value of 1, oh, that's a losing position for max, so this would be a negative 1. Okay, and there's similarly here, negative 1. Okay, we move up. We are in the min level, so we're going to have to take mins of the children. For 5, it has both 1 children, so the minimum is still 1. For 4, the minimum is unfortunately negative 1, so this will be negative 1. For 3, the minimum is negative 1. Well, they're both actually negative 1, and for 2, it's also negative 1. Okay. We are in max, and we have to take the max. For 7, the max of 1 and minus 1 is 1. The max of minus 1 and minus 1 is minus 1. The max of minus 1 is minus 1. Okay, we have to take the mins again. That doesn't look good here for max. If you take the min from 1 and minus 1, that is negative 1 here, right? So these two these two children here, the minimum, because we're in the min range, is negative 1. And of course, these both children are negative 1, so that's also negative 1. So in the last step, we take the max, but that is still negative 1. So max is going to lose. And now we could ask, how much is max going to lose? Or can he minimize his damage? So what is the worst that he has to pay? No, what is the least that he has to pay? Well, we can also calculate the worst, but let's see. Okay, so remember, it now has, again, levels, right? So this is, the payoff here is, oh, I was going to do this in blue. Let's do it in blue, okay? The payoff was $0. Here the payoff was 1. $2, $3, $4, and this is $5. So this is a, if Max would get here, he would get $5 for both of these situations. Both situations would yield him $5. So taking the max would be 5 here. And the same for 2. The max is 5 now. Now these are losing positions, so these are both now value -4. You see that the signs are still the same? Okay. Now we go up. We take the maximum of 5 and 5. This would be valued at 5. If we take, oh no, so the maximum, the minimum, sorry, we are now in the min situation. If we take the minimum of 5 and -4, that is a -4. And the same here, negative, this will also be -4, and I hope you see that this is also -4. So in the next level, we're going to take maxes of 5 and -4, so this is now valued at 5, but the max of -4 is -4, and the max of this is also -4. Therefore, in the last, no, the penultimate level, we have mins again. Minimum of these two is -4. And here, the minimum is also -4, so -4. So he has to lose $4. And if he's not careful, he could lose, well, I guess that's, yes, he always loses $4. He can only hope that the other guy screws up and he loses less, or he might win. So, okay. Okay, I wanted to say something, but I forget now what it was that I wanted to say. No, okay, that's it. All right, thank you. And, oh, this is the homeworks. What do you do? Yes, it's all homework, sorry. We will be quizzes, both a Huffman coding quiz, what we did first, and the second quiz will be a game quiz. The game quiz probably is the more work, right? So be prepared. But I do them separately. Each quiz